This is section 6.5. We're going to find an equation for a line given the slope and a point. Any point. We should know already the equation of a line given the slope and the y-intercept, right? We know that already. We just plug in those values m and b, and we have our equation of the line. Today we're going to be finding the equation of a line if we have the slope at any point, okay? So the slope of a line gives its direction. For any given slope value, there are many possible lines. So there we can see an example of that. This family of lines has a slope of a half. How many different lines share the same slope? How do you know? What additional information would you need in order to pinpoint a specific line? So you can imagine there's probably an infinite number of lines that can share the same slope, right? With all different equations and all different y-intercepts, okay? One thing that is unique about each line is that every point that it passes through is unique in the sense that another line that's parallel to it will not pass through any of its points. Agreed? Can we all see that by looking at these lines? Yeah. If this line here is passing through 2, 0, no other line with this slope will pass through 2, 0. Okay? So knowing that then, if we have any point on the line and the slope, we should be able to figure out the equation of that line. Okay? Suppose that you know that a line with a slope of 1/2 passes through the point 1, 5. There's only one line that does this. In fact, if you know the slope at any point on a line, you can identify its equation. So that's what we're going to do. So it says find the equation of a line with a slope of a half that passes through 1, 5. Before we look at the solution here, any ideas how we might do this, Christian?
Because we know the slope, we can plug that in for m, and then because we know the x and y point, we can plug in 1 for in y.
Wow.
Y equals m.
You might as well teach the class because it's exactly what I'm going to teach you. You're exactly right. Okay, perfect. Perfect answer. He said because we already know the slope 1/2, we know all equations of a line look like this. Christian said, well, I'll just take that 1/2, I'll plug it in for the m. I also know a point, so I'll take x, plug it in for x, take y, plug it in for y, and then I'll move things around and figure out what the value of b is. That's right, Christian? Yeah.
They did that for the Khan Academy lesson yesterday.
Oh, did they?
Yeah.
Yeah, that's kind of the reason I give it to you in advance is so that you do have... You don't know how?
6 hours from now.
Okay, so we'll pay attention. We're going to show you. All right, so that's the idea here. So we can see here, substitute x equals 1 and y equals 5 and m equals 1/2 into the slope and y-intercept form an equation. So we can see that happening. So 1/2 goes in for m, 1 for x, 5 for y. And then we isolate b. So they left it on the right-hand side, which is fine because it's positive already. We move things around and we solve for b, which is 4.5 or 9/2. Okay. I personally prefer irregular fractions in lowest terms as opposed to mixed numbers. But either one would be correct. That's what I prefer. I think the 9/2 looks cleaner than a mixed number. Any questions on how this was found? Okay, what's the last step? We have B. Joseph.
You would find the same answer if you used 0.5 instead of 1/2?
Yes. Right, because it would have been 0.5 here. It would have been 5 minus 0.5, 4.5, right? Which is the same as 9/2. You're allergic to fractions, Joseph.
Yep.
Yeah, okay. Yeah, Tyler.
So this only works if you have like these 3 pieces of information?
Well, there's 2 pieces, the slope and any point. Okay?
So depending on what coordinate they give you, that's going to dictate what your
Subbing in.
mx and
Yes.
what your mx is?
What your xy is.
Oh, okay.
Your m is the slope. All right. So the last point I was getting at was that you then take that value of 9/2 and you just plug it into the equation of a line, which is there. Okay? Second question says graph the line. We should all be familiar with how to graph this now. So the starting point is always the y-intercept. So you go up to 4.5, and then you're going to rise 1 every time. Yes?
Is there any badminton tournament today?
Badminton, I have no, the badminton is not a sport at this school.
Okay, so there wasn't.
No.
Okay, thank you.
Okay. So we start at the y-intercept, and we know our slope is 1/2, so we're gonna rise 1, and we're gonna run 2. Okay? So we rise 1.5. Sorry, we rise 1, so we get to 5.5, and we run 2. 1, 2. So there would be our first point. Okay? How can I find out any point on this line? How could I find out what, let's say, this point? Can anyone tell me? How can I find out the exact value of that point? Yeah.
Oh, so you would just plug in the formula? You would just plug in your x value into the...
Right, but I wouldn't plug in x in this case. I'd plug in y. And why would I plug in y, Sal?
Because it's the b with the y-intercept.
No? Yeah, Nicholas.
X is unknown.
Yeah, well, they're kind of both unknown right now, but the point is that I would plug in y is because I can see the y value is clearly on the line 3. You guys see that? Whereas my x value is kind of, yeah, unknown, right? Not sure. So to find out any exact point, if you plug in one value of x, you can find the exact value of y, right, into the equation. Okay? I just want to make that point clear, that you can get any of these points if you know one of the coordinates. You can plug in and get the other. Example 2. Steven?
Gina knows that it costs $25 to take a taxi to work, which is 10 kilometers from her home. She forgets what the fixed cost is, but remembers that the variable cost is $2 per kilometer. Her friend lives 12 kilometers from Gina's home. Gina has $60 to spend on the weekend. Can she afford a round trip to see her friend? A. Find the fixed cost and write the equation that relates the cost in dollars of a trip to the distance in kilometers.
All right, so let's just write the equation first before we find anything. What would be the equation for this particular example? Adam.
C, or cost, equals 2v for distance plus 5.
Plus 5. How'd you get 5?
Because there's 10 kilometers, so $2 times 10 kilometers is $20. So 25 subtract 20 is 5.
Good, okay. So you did a lot of math just to get that, but originally we wouldn't have that, right? That's what we're actually going to find out, right? So here we could put in, what, b, right? That's our y-intercept. Okay. Sorry? And we might put x instead of d there. Tim, you had a question? Tim? No? Okay, so we're going to do that math that Adam did there in his head. We're going to figure that out. So find the fixed cost and write the equation that relates the cost in dollars of a trip to the distance in kilometers. All right, so we know that it costs $25 and it's 10 kilometers. So we take that 25, we sub it in for C, and we take 10 and we sub it in for D. And that'll allow us to solve for B. Okay? So we have 25 equals 2D, or sorry, thanks. Let's do that again. 25 is equal to 2, the distance is 10, plus B. Alright, so B is going to be equal to 25, sorry, I messed this up. 2 times 10, thanks. That worked out. 25 minus 20. B is equal to 5. Everybody understand? Tyler?
So, but doesn't she want to get to her friend's house as well, so wouldn't it be 10 plus 12? So it's on fixed cost.
Yeah, we haven't got there yet. We're just developing a formula. So when we develop the formula, Tyler, we want to use the known point Or in this case, it was a value of $25 for 10 kilometers. That's our point, right? Our point is 10, 25. That was the given point, and the slope was given as 2. Okay? So using that point and that slope, we can figure out the b value. Once we do that, we have our equation of the line, which is going to be c is equal to 2d plus 5. Any questions on how we got this formula here? Everyone's clear with that? Okay, now with that formula, we can answer really anything we want, right? So graph the linear relation. So here's a general graph. C equals md plus b. Notice there's no units. They haven't figured out this value yet. But if we were to put values here, we know this is going to be 5 here, right? This m value is 2, the slope, and then it should cross through the point 25, so that's 5, 10, 15, 20, 25 is up here, and 10. Okay, we'll see a better graph on the next page. So there's our answer to A. This is what we just did. We substituted in 10 for D and 25 for C. We solved for B. We developed our equation of the line. Not sure why they're using N there as opposed to D. It really doesn't matter. It's just a variable. Could have used X, right? Finally, B, we know the intercept is at 5y. And to find the slope, we know is 2. So we found these other points just by going over 1 and up 2. Remember, a slope of 2 is rising 2 and running 1. So from 5, we rise 2 to 7, and we run 1. So we have 1, 7. Rise 2 to 9, and then we run 1 to 2, 9. Any questions on how these points were found? No? Everyone's good? All right. Finally, the last question asks, find the cost of a 12-kilometer trip. Can Gina, who has $60 to spend, afford a round trip of this distance? Tim.
So first you would find the equation.
Okay, so you want to write this equation out to...
Goes 2d plus 5.
Okay.
And you replace 12d.
Good. Yep. That'll give us the cost for one trip, right? So let's do that. So we get 2 times 2. Okay. So we get $29. That's our one trip, but because it's a round trip, we need to multiply by 2. So we're going to get $58. So can she afford it? Yes. Adam?
If we know that 10 kilometers is $25, it's 2 extra kilometers. Why can't we just add $4?
You could. How much did it tell us how much it was for the 10
It
kilometers?
said she knows it's $25, and she knows the variable is 2, but she doesn't remember the fixed cost. So the fixed cost doesn't matter if you just add 2.
So it would have been 27 times 2, right?
2
No?
times 2 plus 25.
27, no? $2 more dollars? Or, sorry, $4 more dollars. 29 times 2, yeah. Yeah, you could have done it that way. Yeah.
So when they mean a round trip, they mean a trip going and then going back.
Yeah, that's what a round trip means. Yeah, it's like a circle. They go there and come back. The problem, I guess, Adam, with that is that you will get examples that are more complex than this. There might be decimals. So, it's good that you can reason it out, but you also need to know the process, right? It's actually more useful to know this method than just figuring it out. Because as stuff gets more complicated, you won't always be able to do that. Tyler?
No, I was just gonna say, I got confused about the round trip, because I didn't know what they meant by.
No, you guys haven't heard that expression?
No.
Round trip? No?
I thought what they meant round trip was like she's going from her work to then this year.
No, it just means there and back. Okay, there's the $29 times 2, 58, so she's good. All right, sometimes the properties of parallel and perpendicular lines are useful in finding the equation of a line. What are those properties again? Who could tell me? Joseph in the middle.
Parallel is when the
Yeah, but what's the property of the line? So what do two parallel lines have in common? Yeah, the slope is the same, right? And what about perpendicular, AJ?
They're like reversed and they meet at 90-degree angle.
You're right. The perpendicular means they meet at 90 degree, and they're reversed. What do you mean more specifically than reversed?
Like you switch the fractions, and if it's positive, you change it to negative, and if it's negative, you change it to positive.
Excellent. So, Justin, if I had one line that had a slope of -3, and then I had a perpendicular line to that, what would the slope be?
1/3.
Yes, good. -3 flips it, 1/3, and changes the sign. Okay, very good. Nicholas, what about if I had a slope that was -1/7? What would the slope be of a perpendicular line?
-7/1.
I have to change it.
No.
The positive.
You got to change the sign as well.
7/1?
Yeah, positive. Okay? You got it, right? You just forgot?
Yeah.
Okay. And Max, if I had a line with a slope of 8/1, what would the slope be of a parallel line?
8/1.
Ooh, nice. I couldn't trick him. I tried. All right, very good. So, for example, we have these two equations are parallel lines. In both cases, m equals 3. Okay, there's our two lines. Perpendicular lines have slopes that are negative reciprocals. The product of the slopes of perpendicular lines equals -1. So in other words, it's the negative reciprocal. Okay? They're showing that here. So 3/4, this would be -4/3. And there's your corresponding lines. All right, so we need to keep that in mind as a little quick review from the last section. And we're going to need that for example 3 here. Yeah?
Perpendicular lines don't have to meet on the y-intercept, right?
No, they don't. That was a coincidence. Find the equation of a line parallel to x minus y minus 12 equals 0. All right. Can we say that the slope of this line is 1? Sebastian, what do you think?
Yes,
Yes? How come?
because it's 1x and 1y. So.
You're right, but is it maybe a good idea to say that right away? That it's 1? What might you want to do with this line first, Sebastian, before determining the slope? You're right, it is 1, but what might you want to do first?
Put it in a different form.
Yeah, what form?
Oh, I can't remember what it's called now. But y equals
mx plus b, yeah. It's just called Y-intercept slope form, okay? Yeah, the reason why is because it's not always what's in front of x here. Because if there's a number in front of y, the slope will change, okay? Christian.
I'll ask if I can solve for it.
Oh, sure.
To solve first, what I do is I bring x and -12 to the other side, so it becomes -x plus 12.
Okay,
So y equals -x plus 12. Negative y equals -x plus 12.
okay,
But then y can't be negative, so we have to multiply everything by -1.
right.
So it would become y equals x minus 12.
Yeah, very good. Perfect. So now we have it in the form of y equals mx plus b, and it's safe to say that the slope is 1. Yeah,
So is it okay if you just divide everything by -1 instead of?
Yeah.
Doesn't.
it's the same thing. So there's our equation of the line. And now we're told that it passes, find the equation of a line that's parallel to this and passes through this. So we know it's parallel to this, so we know the slope of our new line is going to be 1, but it also goes through this point. So we're not done. We need to use this point and our standard form of a line where slope is 1. Okay, there's our line with a slope of 1. We're going to take this value of 2, sub it in for x, and this value of -5, and sub it in for y. So -5 is equal to 2 plus b. b, leave them on the same side, move the 2 over, becomes -7. So the equation of our new line then is x minus 7. Okay? Any questions? It's the exact same as the first examples. The only difference is now we're using another line and what we know about parallel and perpendicular lines to get the slope for our line before we plug in the value. B, perpendicular to 4x plus 5. This is already in our y equals mx plus b form, so we know the slope of our new line is going to be what? Justin?
4.
No.
No. Negative 1
Yes. Negative 1 over?
4.
Yes, negative 1 over 4. Good, yeah. Because it's perpendicular. All right? So that we know the slope is here, and then we take, it says it passes through the origin. What point is the origin? Alvin? 0, 0, yeah. So we just plug in 0 for the y-intercept. We already know what it is, the y-intercept. Okay, if it goes through the origin, we don't have to bother plugging in x and y to solve. We know that the y-intercept is 0 because that's where the origin is. It's on the y-axis. So there's our equation. Okay. If you weren't sure about that, weren't sure about the origin being on the y-intercept. Let's say we would have plugged in 0 for x and 0 for y. We would have got b equals 0. Right? So even if you weren't sure and you went through the exercise of plugging in 0, 0, you would have got b equals 0, and you would have ended up with this equation anyway.